up here. All right, there we go. So, all right, so guys and gals, let's start with the domain question. So try that. What's the domain of that function? So how do we find domain? Yeah, denominator cannot be 0. Or if you have a square root, the inside of the root's got to be positive, meaning greater than or equal to 0, right? We don't have a root, so we just say denominator, you cannot be 0. X squared minus 25 we can factor. The plus version, of course, we cannot. But the minus we can. 1 plus 1 minus. So that means x cannot be 5 or negative 5, right? So that's option B there. Next question they're going to ask us is, what is the vertical asymptotes? How do you find vertical asymptotes? The same exact thing, except it's denominator. Oops, that's a D. That's a demon. Denominator equals 0, right? Denominator equals 0. Because you want those places where it doesn't exist, right? So you say x squared minus 25 equals 0. So it's going to be the same answers. X minus 5, x plus x minus screen, no, little off. So anyway, x is 5 or negative 5. Those are the two vertical asymptotes, and those are the two places the domain doesn't allow you to go. They're the same thing. All right. Finally, how do we find the horizontal asymptotes? What do we do for horizontal asymptotes? Numerator degree, denominator degree. What's the numerator? It's just that 6, so that's a degree 0. Right? Because that's the same as 6x to the 0 power. 0 power, anything to the 0 power is 1. Right? So just a plain old number without an x is like x to the 0 power. It's 0 degree. Right? The denominator is a second degree because x squared. Right? And so who's bigger? The denominator is bigger. What does that mean? As you go to the right forever, as you plug in x is 1,000 and 10,000 and 100,000 and 1,000,000, you plug 1,000,000 into that thing, the bottom is going to win the tug-of-war hugely, right? The bottom is 1,000 squared minus 25. That's huge. The bottom is just going to overwhelm the top and pull the graph down to y equals 0 as a horizontal asymptote. It's got no oblique, no diagonal. Good? That good and all that? Then they just have you use your graphing calculator to pick the right graph once you have those things. All right, I'm going to move on. Whoops, a little quick on that. Since we don't have time for everything. Although I wish we did. So we got this function, and we're going to find, well, I don't need to rewrite it. We're going to find the vertical and the horizontal. So I'll just do it real quick. So what would be the domain? Denominator cannot be 0, so x squared minus 49 cannot be 0. So x cannot be 7 or negative 7. You know the drill. And the vertical asymptote, same thing. X is 7 or negative 7, right? Let's jump right on to the horizontal, which will be more interesting. So how do we find the horizontal asymptotes? Numerator degree is 3, denominator is 2. What does that mean when the numerator is just one more, barely bigger than the denominator? It's going to be an oblique, a slant, a diagonal asymptote, right? Why? Because if you plug in like 1,000, 1,000,000 in for x way off to the right, the top is going to be like x cubed, the bottom is x squared. If you divide those, it's like x to the first power. It's linear. X to the first power means like a line. Y equals mx plus b. So that's why. When the top is just 1 degree higher. As you go way off to the right and plug in 1,000 and 10,000, way off to the right, it's going to head off like a line. X to the first power. Some kind of y equals mx plus b thing. Does that make sense? Because the top's 1 degree higher than the bottom. So as it goes way off to the right, it's going to head off in a linear fashion. It must. So what does that mean? Well, we got to find that line. How do you find that line equation? You got a long divide. Yeah, the bottom into the top, right? So we got to do that. Let's divide. So the bottom, x squared minus 49 into the top, x cubed minus 64. So remember, what could I put up here? Times the front that'll match the front. Remember, it's what times front matches front. So what times front matches front? X, just plain old x. Times x squared makes x cubed. But he also goes there, minus 49x. Everybody good to there so far? Am I whipping too quick? Tracking with me? Remember the long division? Bottom into the top. So you've always got to go denom into numerator. Right? And up here, I'm going to get the y equals mx plus b thing. Whatever it is I get, it's going to be up here. So I multiply. So whatever you put, how do you know what to put up top? Whatever times the front, that'll match the front. Right? What times x squared makes x cubed? Well, x. But it multiplies both of them. You write them both down, and then you what? Subtract. Now, careful. These guys can't subtract. They're unlike terms. It's just going to be minus 49x minus 64. No, plus 49x. Because I'm subtracting minus 49. Ends up becoming plus 49, doesn't it? Watch out for that. Easy to mess up there. Everybody see that? Everybody see what happened there? Right? Because when you do the long division, you subtract the bottom line, don't you? So subtract negative 49 becomes plus. I just put that one first because he's the higher power. Put him, right? These are not like terms. They just come down side by side. One more step. What do I put up here? Times the front that'll match the front. Oh, nothing. Nothing times x squared makes x to the first power. This is all just remainder, actually. Because there's nothing times x squared that'll lower the power down to x to the first. So we're done. There it is. It's just y equals x is the asymptote line. The oblique, slant, diagonal asymptote. Are we good? All right. Harder and leave the easier parts. Might be the best way to use our time. So the domain might be a little tricky here. The domain on this one is going to be denominator, as you know, not equal to 0. So x to the fourth minus 16 not equal to 0. How do you solve that? Yeah, I would just move that 16. You can factor it if you want. Do a bunch of factoring. But you could just move that 16 over, right? Becomes positive 16. And then just fourth root it on both sides, right? Fourth root. But whenever you do an even root, it's plus or minus, huh? Whenever you do an even root, it's plus or minus. Odd roots, no. Is that okay? I don't know if I always want to explain everything, but we don't have time. For example, if you're doing this, you know the answer is only plus 2. You can't do negative 2 cubed to be positive 8, because an odd number of negative signs would stay negative. So you see how if you cube rooted, you don't put plus or minus, you just leave it. So for odd roots, we don't put a plus or minus. When we put a roof on the house, we don't go up and down the ladder, right? We don't do it for odd roots because they preserve their sign. They keep the same sign. But even roots like 4, yeah, you got to put plus or minus, right? Because it could be positive or negative to the fourth power would come out positive, right? So x is plus or minus 2. Fourth root of 16, what times itself? 4 times the 16, 2. Plus or minus 2. X cannot equal. I lost the not equal, so plus or minus 2. The rest is normal on that one. So I'm going to move on. It's a weird thing. If you're going forward in math, Calc 2, you'll have to do this long division thing again. So I'm going to skip the first, well, I could do, oops, I'll start with vertical. Start with domain. Oh, does this thing factor? Well, domain is just denominator not equal to 0, so x cannot be 9. Vertical, though, remember we have to factor. Vertical, you have to factor first. The top, am I on the screen? Barely. Is that top factor? 6 and 9, huh? Minus 9. Oh, it's plus 9, so it doesn't cancel. Whoops, got my x there. Yeah, it's plus 9. How do I know? Plus 3 in the middle. So if you're not sure on that factoring, you just got to FOIL that out. FOIL, FOIL, FOIL. If you're not a good factorer, that means you haven't FOILed enough. Because factoring is foiling backwards. FOIL more until you can think it backwards. That's basically what you got to do. There's no shortcuts. Notice I was great at that test. Some people were great at factoring, some were not. You must master that if you want to go forward in math. So, just if you're not sure why that's plus 9 minus 6, FOIL it, multiply it. You'll see. Anyway, they don't cancel. Nothing cancels, huh? So anyway, so then we just grab denominator and we say equal to 0. So same thing, x is 9 is the vertical asymptote. Remember when it comes to vertical asymptotes, you factor and cancel first. Domain, you do not. See, I didn't even try to factor with domain, right? If the bottom's a problem, it's a problem for a domain, whether it cancels or not. But for vertical, if something cancels, it's no longer a vertical asymptote, although it's a problem for a domain still. All right, I can talk more about that if you want after class or whatever. So anyway, let's move on. What I really wanted to do here was the horizontal oblique asymptotes. So what's the story with the horizontal oblique? The numerator is 2, the denominator is 1 degree. So what does that mean? Oblique. If you plug in 1,000, it's going to be x squared over x, which is x. The top is 1 degree higher than the bottom. So you go way out to the right, 1,000, a million, it's going to go off in a linear fashion, mx plus b. It's going to head off to the right linearly, off and up, right and up linearly. So how do you find that? Denom into num, because it's not just x. You might think, well, that's it, Mr. Why don't you go, it's just x? Well, it was in the other one, but it's not always going to simply be x like that. You have to really, that's just my general feel. Like it's gonna be first degree of some kind. That's all that tells me with confidence. I've got to actually long divide. So bottom into the top, x squared plus 3x minus 54. So what times the front matches the front? Plane x goes to both. X squared minus 9x. Subtract. Okay, watch out. So let me ask you the answer. This is where a lot of people get messed up. Ready? Yes. X squared minus x squared, gone, of course, always. 3x minus 9x, right? Positive 12x, huh? Everybody see that? And then minus 54, but that's actually irrelevant. See why it's plus 12x? Because minus a minus 9. So, okay, next step. Can we do another step? Yeah. What do you put here? Times x that'll match 12x. Well, 12. Positive 12. Be 12x, and who cares? The rest is remainder. So there it is. Y equals x plus 12 is my asymptote line, my diagonal asymptote line. Good on that? Does that make sense? Questions? All right. So I know. Let's try this one. Yeah, so if they give you x plus 3 over x, I didn't show you this, did I? You must make it into one fraction. Yeah, you can't have two separate. They're giving you a tricky form. You must make it into one fraction. All the rules I'm giving you, like numerator degree, denominator degree, all that, that's assuming it's one fraction. So you must make it into one fraction for all the rules I've been giving you to work. So, all right, how do we do that? How do we make those two things become one big fraction? Put this over 1, so it looks like a fraction. And then we got to make the bottoms the same, right? You can only add two fractions when their bottoms are the same. So I got to multiply top and bottom of that one by x. Right? I didn't change him. So now he's x squared over x plus 3 over x. Right? What is x squared divided by x? That's just x. That's just a fancy x. It just looks different. Now, so they have the same bottom, and I can put them together. Right? It's made a common denominator out of them. So now, it's x squared plus 3 over x. Now we can do all the normal rules, and it'll work. Does that make sense how I put that together? So you can't have two separate things. You got to make it into one fraction. The rest is the same, which I don't have time for. Too bad. It's going to be another diagonal asymptote, isn't it? But I don't have time. I'll go dot, dot, dot. So do all the rest like normal now. Denominator 0, not equal 0, and the horizontal asymptote thing. Good. No questions on that? If I flash it off there, since you just saw me do one. All right. So try that one. Put those together, right? Put them together into one big fraction. We cannot have two separate fractions. So x plus 37 over x cubed. We got to put them together. So that means put this one over 1 so it looks like a fraction. And then what are we going to multiply top and bottom of him by? The other one, yeah, x cubed, right. X cubed, so what do we get? X to the 4th over x cubed, which is just a fancy x. And then you can put them together. Oops, x to the 4th plus 37 all over x cubed, huh? Is that good? Made it one big fraction, and then all the rest of the rules are normal. Questions I can answer? All right. Yeah, so on this one, just graph it on your calculator. Do not, here's what I wanted to write for clarity. Do not need to make into one fraction because we're only using the calculator. We're not finding, they're not asking us to find, domain and vertical and horizontal asymptotes by hand. They're not asking us to do any of that stuff. So we don't really need to make it into one fraction. Just type it into your calculator and do the minimum thing on your calculator. That's all that's required. These will be quick for you. All right. All right. Big old word problem here. All right, let's do it. So I was happy to see there's a lot of A's and there was a lot of B's on the last exam. That's good. That's good. So I'm saying that because we're looking at a big word problem, which can be intimidating. But a lot of you guys and gals are right on track. That's great. If you're having any trouble, I'd be glad to help you office hours. But most of you guys, a lot of you guys are right on track. So that's good. I'm having fun. Are you having fun? I'm having a lot of fun. Everybody I talk to this semester, I normally teach basic algebra and below all the time. Honestly, just because it's quick, This is a little more work. I had to grade, But I'm having fun. I like teaching people that are, a lot of you guys, you're getting A's and B's, you're on track for calculus and beyond. I enjoy that. So come see me. I'd be glad to help. I'm having fun here. I hope you are. All right, let's do these word problems. Rectangular area adjacent to a river. So basically, I'll cut through all the words there. There's like a river, and they want us to build a rectangle next to the river with 3 fence sides like that. And they're going to give us a couple facts. Basically say the area is 1,500 square feet. And the fence for the side parallel, is that off the screen? Parallel to the river is $9 per foot. Parallel to the river. This is parallel to the river, right? So to call that, well, here, I'll just put the 9. It's $9 per foot. That fencing costs $9 per foot. And then the fence for the other 2 sides is $3 per foot. So fencing here is $3 per foot, and down here as well, $3 per foot for those 2. And the 4 corner posts are $25 each. So corner post, corner post, corner post, corner post. Those are $25 each. Let X be the length of one of the sides is that word on there? Yeah, perpendicular to the river. So that means this is X and this is X. Those are the sides that run into the river, perpendicular, right? What's the other side? I don't know. Call it Y. Just call it Joe. Whatever. We're just giving them a name, right? Okay. So what do they want from me? They want me to write a cost equation. See that C of X? And they want it to eventually only have X. We've done this before. You write it with X and Y at first, then you find some other formula for Y and you substitute into the cost one to make it all X. Huh? It's going to be the same game again. All right, here we go. How do we find the cost of the fencing? The cost to build all the fencing for those animals. Animals are expensive. I don't know if you know that. I've spent a lot of my money on horses especially. Horses are crazy expensive. All right, anyway, I won't tell you about my problems. But so how to find the cost of the fencing to contain them critters. So basically it's $3 a foot times X feet, right? So that'd be 3X for the bottom, 3X for the top, and 9Y for the right side. Is that good so far? And then we have, am I still on the screen? 4 corner posts at $25 each, $100 in other words. That's the cost of the fencing. We just got to make it all X now. But so far so good. Does that make sense? Because, again, the fencing down here is $3 per foot. So like if you had 10 feet, it would be 3 times 10. So we have X feet. So it's 3 times X. And that's 3 times X. And the right side is $9 per foot. Y feet, 9 times Y. Add those up, plus the 4 corner posts, $25 each. 4 times 25, $100. So there's the total cost of building the fence to contain the critters. So now, let me just clean that up a little bit. That's 6X plus 9Y plus 100. We're happy with that formula, except we don't want Y. They want C of X, right? The original question says, give me C of X. They only want X, no other letters. They're fine with the 100. They just don't want any other letters. So what do? I need some other piece of information that I haven't used that will establish a connection, a relationship between X and Y. What other piece have I not used? What other piece have I not used? Yeah, right there. Area. Haven't used that yet. How do you find the area of this shape? How do you find the area of any rectangle? One side times the other. Call it length and width, or base and height, or X and Y. Whatever you call it, it's one side times the other, huh? So the area, if I can put this over here in a different color, so the area is 1,500. That means X times Y is 1,500. Right? That makes sense? Just one side times the other. So what? Well, then I can solve for Y, divide by X. So Y is 1,500 over X, and plug that in for Y. So the cost function will now be, 6x plus 9, and I'll put plus 100 out here, and then we'll put in the Y, 1,500 over X. Does that make sense? We have it in as X is the only letter now. We made a cost function that only has X and numbers, of course. There it is. Now the rest of the questions are basically, well, I don't know what they are. I assume I know. They're going to basically say, they're going to have you eventually type that into your calculator and find the minimum, because you want minimum cost. That's what I want for the animals in my life, is minimum cost. But it never seems to work out that way. So, right, so they're going to want you to minimize that function on the graphing calculator. Type this into y1. We did that, a couple weeks back, right? Type that in for y1 equals. And by the way, since you're going on the calculator, you don't even have to simplify that. Just type it in straight. Well, they might make you simplify it for part 1 here. Yeah, you probably have to. Yeah, maybe I should show that. You would just multiply, right? It would just be 6x. This is 9 over 1. So we have, what's 9 times 1,500? 13. 5 over X plus 100. Yeah, so there it would be. That's what you would type in for part 1. And then part 2, they'd eventually have you type it in your graphing calculator and graph it. I think the rest will be easy. I better get on to the other word problems. Questions on that one? Okay, so it says volume equals 8,500. It's got all the sides. Express the surface area. All right, so how much surface area? Well, first off, let's do the front here. What's the surface area of that front? X, yeah, it's always one side times the other for a rectangle. It's X times Y. Can you see that this is X, and this is, over here, Y. Y is the height all the way around, huh? So it's X, so the front, so we have the front and the back, and they're both just XY and XY, aren't they? Front and back. And then there's the right side and the left side. And then there's the top and there's the bottom. There's 6 sides altogether, huh? So if we're adding up all the surface area, all the surfaces, we've got 6 sides. Front and back, right and left, top and bottom. So the front and the back are both XY, XY. What's the right and the left? What's the right side? Let me go over here and shade the right side. Here's the right side. What's the area of that right side? Same thing. Huh. X times Y. And the left side, over here the left side, X times Y. They're all just, the 4 sides around, the top and bottom will be different, but the 4 sides around, right? The front, here's the back. I never showed the back. There's the back, X times Y. They're all front, back, right, and left are all just X times Y. But what's the top up here? Yeah, that's and same thing as the bottom. The top and the bottom are x by x, aren't they? So the top and the bottom are a little different. They're both just x by x squared. Is that good? So what do we get? This is 4xy plus 2x squared. That's the surface area. But they want it only in terms of x. So that's the surface area in terms of x and y. But they don't want the y, so what am I going to do? Come up here. There's the other relationship I haven't used. Volume. What's volume of a cube? Yeah, just the three sides. X times x times y. X times y. Length times width times height. We good with that? Length times width times height. So it's x and y. So in other words, x squared y is 8,500. Solve for y. Divide by x squared. Y is 8,500 over x squared. Plug it in right there. 4x, 8,500 over x squared plus 2x squared. There's the surface area formula in terms of x only. Is that good? Does that make sense how I'm doing that? You can clean it up a little bit. Put this over 1. This x will cancel one of these, huh? And what's 4 times 8,500? 32 into a 34, like 34,000 or something? Is that what it is? I think that's right. Over x plus 2x squared. Oh, I'm way off the screen, huh? Plus 2x squared. All right, one more we got to do. All right, so they want us to find for this can the surface area. They're basically telling us it. So the surface area in terms of r, well, it's going to be the lateral is 2 pi rh. They're just saying it. That's lateral means sides, all the way around the soda can or whatever, plus the top, pi r. So this is the sides, the top, and the bottom. Another pi r squared. They're just handing it to us. They're just showing it to us in the picture, huh?
Would you do two sides or?
Yeah, good question. The side it's all the way around, huh? It's not like a front and a back. It's just all the way around the sides. Is that 2 pi r h formula? 2 pi r is the circumference times the height. That's how they're getting that. It's a rectangle that's 2 pi r wide. Right? If you, I don't have time, but if you take a like a soda can kind of shape. Right? And you slice it open, it becomes a rectangle. And how, okay, great, so the height is the height, that hasn't changed, but how wide is it? How far around the circle was, which was 2 pi r, circumference of a circle. Not pi r squared, that's area in the middle. 2 pi r is the width, huh? 2 pi r h. That's how they're getting that formula, 2 pi r h. So anyway, there it is, but they want it in terms of r only, so you got to do something, I don't know what. Oh, and you got to do the money. Yeah, 9 cents per square centimeter for the top and the bottom. So this has got to be pi r squared times 0.09. And this has got to be pi r squared times 0.09. And it's 8 cents for the sides. So 2 pi r h times 8 cents for each square centimeter of that. And then we need some other formula. What is it? I don't see it. Oh, the 60, I've written over the top. There it is. 500. The volume is 500. Oh, you need to know volume, guys. I better do this before I let you go. What's volume of this shape? Pi r squared h. Pi r squared, circle on the bottom, times the height. Pi r squared h, that's the volume. So 500 is pi r squared h, right? Solve for h, because they want only r. Solve for h, divide by pi r squared. Pi r squared. So h is this. Plug that in for h, and that'll be your formula. Is that okay? We're over time a little bit. Thanks for waiting. All right, we're done. This section is due tomorrow, section 4.3.